Hello, class 7. Welcome back. In today's discussion, we are going to study in chemistry oxygen. It is the second abundant gas that is found in the air after nitrogen. Now, by volume, it is 21%, and by weight, it is 23% of the total air that is in the atmosphere. Here are the details of oxygen. Its symbol is O, capital O. Its atomic number 8. Molecular formula is O2. That means one molecule of oxygen consists of two atoms of oxygen. Two atoms of oxygen make one molecule of oxygen. So its molecular formula is O2, indicating two atoms of oxygen in one molecule. Atomic weight is 16. Its valence is 2, molecular weight 32, color is colorless. Odor means smell is odorless. That means it has no smell. Now about molecular weight, valency, atomic number, these things you can study in higher classes about oxygen. But these are the details given in the book, so I discussed with you. Now, in the history, we find about two scientists. One is Joseph Priestley, who actually initiated the discussion, or he discovered this gas called oxygen. It was not that it was not present in the air before, it was already there, but he found out this about this gas in 1774. And then in 1776, a French scientist, Lavoisier, he studied more about it and gave his study about oxygen gas. And it was Lavoisier who named the gas oxygen. Before that, there was no name given to this particular gas. Now, on page 110 of your book, here 110, there has been given a particular experiment. I'm not going to discuss the full experiment, neither are you going to study about it. It is not going to be asked in exam also. The gist of the experiment I'm just going to share with you. It says that this experiment is all about demonstrating the presence of oxygen in air, to show that in air there is this particular gas called oxygen. Now, for this experiment, what we require is magnesium ribbon. Now, magnesium is a substance, it is in the form of ribbon, and then you have these particular apparatuses. This is called crucible, in which the magnesium is kept and it is heated. Then you have this tripod stand. Tripod has actually three stands. One stand is hidden behind this Bunsen burner. Bunsen burner is required for producing fire. Its connection is there with gas. You can see there's a pipe coming out from this. So through that gas, it produces the fire. Tripod stand, heat mat. Here is heat mat. Pair of tongues. Tongues is like a pair of scissors. It is meant to hold the magnesium ribbon when it is burning. So all these apparatuses are required for this particular experiment. Now I'm just going to tell you about this experiment. What they do is they take this magnesium ribbon and burn it in fire. First of all, the weight of the magnesium ribbon is determined and it is noted down. And after burning of this magnesium, the product that is formed is magnesium oxide. The weight of that magnesium oxide also is determined. You will see that there is a difference in weight. Magnesium before burning and magnesium after burning when it forms magnesium oxide. The weight of magnesium will be less and the weight of magnesium oxide that is formed after burning of magnesium will be more. So from this we actually conclude that there is oxygen, because the product after magnesium is burned is magnesium oxide. That oxide is nothing but oxygen. Here is the reaction. Magnesium, when it burns in oxygen, produces magnesium oxide. The weight of this magnesium oxide is more than the weight of magnesium. So what had happened? Magnesium, when it is burnt in fire, it reacts with oxygen. So after it reacts with oxygen, magnesium's weight becomes more. So this proves that air consists of oxygen gas. Okay, air consists of oxygen gas. Here it is given. What do you observe? After this experiment, when magnesium is burnt in air, the product formed is heavier than the reactant. Okay, the reactants are these, magnesium and oxygen. The product is this, magnesium oxide. This weight is more than this magnesium. So due to gain of oxygen from air, the weight of magnesium oxide is more than the magnesium. So from where did that weight increase? Its weight increased because it absorbed oxygen from air. So this proves that air consists of oxygen. Now we are going to look into the laboratory preparation of oxygen. That is, how oxygen gas is prepared in the science lab. For preparation of oxygen, we need a chemical. It is in the form of powder, okay, white powder. Potassium chlorate, this is a salt. It is in the form of powder. Potassium chlorate, when it is heated at 600 degrees Celsius, then the product that is formed is potassium chloride and oxygen. Here it is shown by an up arrow. Up arrow is shown for those gases which rises up. I mean, for gases it is shown. So here the oxygen is produced in the lab by heating potassium chlorate at 600 degrees Celsius. Alright. But this producing of 600 degrees Celsius is very hard. So for that purpose, we use a catalyst called manganese dioxide. Here is the formula, MnO2. When potassium chlorate powder along with manganese dioxide as a catalyst is heated, then it does not require 600 degrees Celsius. It requires only 240 degrees Celsius. Hence, the speed of the reaction is speeded up. You don't have to wait for the temperature to be 600 degrees Celsius. So it starts right at 240 degrees Celsius. That is the purpose of a catalyst, you know. Purpose of a catalyst is to increase the speed of reaction or decrease the speed of reaction. So here it is increasing the speed of reaction. So when potassium chlorate salt is heated along with manganese dioxide. Now manganese dioxide will not react with potassium chlorate. Remember, catalyst, it does not take part in the chemical reaction. It only helps to speed up or speed down the rate of the reaction. So here potassium chloride along with manganese dioxide, when it is heated at this much degree Celsius, then you can see oxygen gas is produced. And you can see in the product also the same manganese dioxide is there. It has not reacted with potassium chlorate. Before the reaction how it was, after the reaction also it will be as it was. So it is only helping in the speeding up of the reaction, manganese dioxide. Okay, you can see here the diagram that is given over here. Here this is the test tube in which combination of potassium chlorate salt and manganese dioxide are kept. Here is a Bunsen burner. This is a wooden stand to raise the position of the Bunsen burner to this height. It is heating this test tube, and inside the test tube you have these two chemicals, potassium chlorate and manganese dioxide. So oxygen gas is evolved here, which is passed through this delivery tube into this gas jar. Now remember, this particular gas jar, it is filled with water. But initially it was filled with water till this level, till its maximum level. But when the gas oxygen is released, it is, see, you can see here, bubbles of gas are released. This gas comes and occupies this space, and it starts pushing the water downwards. That's why now this gap is created over here. This gap was not there initially. The water was still here, full to the brim. Okay, this gas jar, the water was still here. But when the oxygen gas is released, it starts getting evolved here. It starts to take up this space, and so it starts to push the water downwards. That is why this method of collection of oxygen gas is called downward displacement of water. Water is moving downward, and in that gap oxygen gas is collected. Okay, you have to make sure over here that this container and the gas jar, you seal it with Vaseline so that there is no gap between this and this area. So you seal it with Vaseline, all right, and initially the amount of oxygen that is produced, that you should not allow it to get collected. Allow that gas to be released. Then afterwards, the remaining gas which is produced, that you allow it to pass through the delivery tube and get collected. The initial amount of oxygen gas is impure, so let it pass through. Don't collect that. All right. So this is how in laboratory we manufacture oxygen gas. I am going to post a video of the preparation of oxygen with the help of potassium chlorate and also with the help of hydrogen peroxide. There is another chemical. All right. So that will come after this video. You just see that video for your educational purpose. All right. So these are the methods of preparation of oxygen.